Hey guys, this is Felix from lowpowerlab.com, and in this video I'd like to show you how I modified an aquarium air pump to make this manual SMD pick-and-place apparatus to help me with assembling my PCB boards. I've seen someone else build something similar, so I decided to give this a try, and as it turns out it's a very effective tool for assembling PCBs. It's much better than assembling under a microscope using tweezers or something similar like that. So what this is, it's a regular aquarium pump that I bought from the local pet store. Nothing special about it. I just opened this up and you'll probably find an air intake in here, and I bought a bunch of aquarium air hose that I ran through a hole that I drilled on the side, and then I attached the hose to that air intake, and I used a rubber seal and a bunch of silicone to make it airtight. And then at the other end I used this syringe, and the syringe comes with a rubber seal that I poked with the air hose to make it airtight. And I also applied a bunch of silicone just to make sure this is sealed. And then the tip is a syringe needle that I cut and bent at an angle that's convenient for picking components. And also finally, one of the most important parts of this is I drilled a hole on the side of the syringe cylinder, and that acts as a pressure switch, and as long as I keep it covered, there's going to be vacuum and components will be picked up, but as soon as I uncover it, even partially, components will drop off. So this is very convenient to pick components up, and then as soon as I want to drop them off, I uncover the hole and then components will drop off. I also built this switched outlet. It's all parts from Home Depot. It's a junction box, an outlet, and a light switch. And this cord I got from a TV teardown. It's a polarized cord, and what this is making sure this only goes one way into a regular outlet to make sure that the switch is always switching to hot and not to neutral. And this is very convenient for using it on a tabletop, like with this pump. I just plug this into an outlet. I plug this pump here, and then whenever I want to turn it off or on, I just flip the switch. So this is very convenient. Now what I'll do is I'll tear down the pump and show you what's inside and how I modified it, and then later on I'll show you how I actually use the pump for rapid pick and placement and assembly of a couple PCBs. So here's what I did. I just there was a hole here that was providing the air supply for the pump, and then I just covered that with a rubber seal, and then I wrapped that up in silicone, let it cure for about a day, and then I made a hole on one of the sides of the cover, and then I ran the hose through that into that rubber seal, which keeps it tight. And that's all it is. It's very simple. Next up, I just want to show you how I actually use the pump, and I will spread paste on a couple boards and then use my tool to pick and place all the components and then actually bake the boards and end up with something like this, a fully assembled board. Now to spread the paste, I use this homemade SMD metal stencil that I made from a soda can. You can see my other video tutorials on how to make these. I'm using a solder paste that I bought online and a credit card to spread the paste. I taped some scrap PCBs on the table, and then that acts as a jig for the target PCB. So this is held in place by tape. I just put my PCB in there. I cover it with a stencil, and then I wipe the paste across to spread it on all the pads evenly. This works very well. It's much faster than trying to use things like solder paste dispensers and things like that. That'll take forever. So you'll see this is very, very fast. So what I'm going to do is just grab some paste, mix it a little bit because I just pulled this from the refrigerator, so it's kind of tacky. So this likes to be mixed a little bit before I use it. So I'm just going to make sure the PCB is aligned with the stencil. I apply some paste and then I drag it across evenly, applying even pressure. Here it is. I also want to show you this. It's a piece of cardboard that I applied a bunch of double-sided tape to it so the component strips will stick to the cardboard, so I don't have to mess around with dumping components on the table and then half of the components will be turned upside down and have to spend a lot of time aligning the parts and turning them, things like that. Also, it's very ideal for polarized components like LEDs. So this way I know that the LED is oriented this way, and I can easily pick and place that component with this tool on the board every time, saving me time and not having to look through the microscope or figure out which way the component is oriented. This is also very useful when you have components oriented in different ways on your board. So if you have a bunch of boards that you want to assemble, you don't want to keep turning the PCBs. Instead, you can simply turn this to help you pick components that are aligned this way, and then if you have components that are aligned that way, perpendicular instead of horizontal, you can just turn this cardboard and then pick the components and place them on the board. So I'm going to actually show you how I assemble 4 boards. So you see how this goes. It's pretty quick. And what I do is I turn on my pump. Hopefully you can still hear me. And I'm going to start with the first component, which is the resistor. You can hear the pump in the back humming, working harder when I'm creating the vacuum to pick the component and place it on the board. And here's an assembled board. Again, not all the components are perfectly aligned, and that doesn't really matter because their solder paste reflowing will pull the components into place and align them with nicely with the pads, so you don't have to worry about that too much. Here's my super cheap toaster oven that I use for reflowing. There's nothing special about it. I didn't hack it to add temperature control or anything like that. It's just bare bones toaster oven that I'm not using anymore, and I just place the components inside. I turn it on. I use my fluke meter to measure temperature with a KT thermocouple, and then I just turn it on up to about 140 degrees Celsius, and then I let it sit there for about a minute and a half or 2 minutes. That temperature will still climb to about 160, and then it'll start dropping. At that point, I turn it back on until it reflows. And I'm using clean, non-leaded solder paste, so this will reflow at around 220 degrees Celsius. So at this point, I'm turning it off. Temperature will still climb to about 160 degrees, and then start dropping. So that takes about a minute and a half to happen, and then at that point I will just turn the oven back on and just let it climb up to 220 degrees where it should reflow. We're at 200 degrees right now, and I'll start watching for the parts to reflow. Not sure how visible this is going to be, but I'm going to do my best. When the parts reflow, the joints are going to turn shiny, and it's pretty obvious. We're at 217, and the parts just reflowed. You can see how nicely they're aligned with the pads right now. So I'm just going to open the door slowly and let cool air go in. I don't like to take these out too sudden because that might cause a temperature shock and damage the dies. And also, if the solder is not solidified, it might jerk the parts off the pads. So I like to let it cool down for like a minute before I pull them out. Here's a finished PCB. All the components seem to be pretty well aligned, and I'm pretty satisfied with the outcome. And I hope you enjoyed this video. I hope you will get inspired to build a tool similar to this to help you with hand placement of SMD components. It'll be much faster, in my opinion, compared to tweezers and a microscope. This whole setup probably cost me around $20 for the pump, the hose, and then this switched outlet that I built to help me switching on the pump. So it's very low cost, and you should probably try it. It'll only take you like an hour to modify the pump, and then another half hour to build a junction box like this. Or you could even plug this in directly. You don't have to build this, and then your cost will be around $15. Thank you for watching, and please subscribe to my channel to get updates when I post new videos, and check out my blog at lowpowerlab.com. Catch you next time.